So welcome to the test 3 review for 1033C, intermediate algebra. Let's go ahead and begin. We got 20 questions that all come from chapter 4 through chapter 5, and they do go in order, so I will let you know as we move through what section is what. So the first thing is we start off in 4.1, and they want you to find the domain of the function. So we got this function a of x equals x plus 8 all over x minus 5. So remember, in order to find the domain of this, all you have to do to find the domain is set the denominator equal to 0 and solve. Okay? So we're going to set this denominator equal to 0, x minus 5 equal to 0. Solve for x, add 5 to both sides. X is equal to 5. So our domain then is that we like every number but this, because this is what makes our denominator 0, and that's bad because you can never divide by 0. So if you plugged a 5 in, that makes this guy 0, and that's why we like every number but 5. So 5 gets thrown out of the domain. So this is the set notation. If it wants interval notation, it would look like this. We like all numbers but 5. So we're going to start at negative infinity. We're going to go up to 5, and then we're going to jump over the number. This represents that jump. Parenthesis, union, parenthesis. And you're going to pick right back up on the other side of 5. This right here, parenthesis, union, parenthesis, is like we're going to jump over the 5 because we do not like 5. And then we're going to pick up with everybody else from 5 and above. And that's what the interval notation looks like. Okay? So if it asks for set, you throw out 5. If it asks for the interval, it looks like we're inviting everybody, but we're going to jump over the 5 with a parenthesis, union, parenthesis. Okay? So that is the answer to question number 1. And there are the two different kinds of answers that you could be asked to put in. All right, let's jump into question number 2. So question number 2 says find the domain again. So we got this a of x equal to 5 over x squared minus x minus 12. So all we're going to do is take that denominator and set it equal to 0 again. Now we have x squared minus x minus 12 equal to 0. So this needs to be factored. Now in this chapter, chapter 4, and through the rest of the year, you should actually know how to factor. So I'm not going to show you how to factor this. You need to know that by now. You need to be good at factoring by now. So this, when you go through your factoring, it is a trinomial. So depending on your professor, you could use the AC method. You could use slide and divide if you learned how to do that. You could do a box method if you learned how to do that. I know Mr. Armstrong's class taught that. You could do guess and check. You have like 4 different ways to get through this. But it should factor to x minus 4, x plus 3 equal to 0. So remember that we have a rule called the zero product rule that says when you have two ideas being multiplied together and they equal 0, one of them is equal to 0. So all I'm going to do is set each one of these parentheses equal to 0. Once it's factored, that's what you do in order to solve for x. Once you got it factored, take one of your parentheses, set it equal to 0, take the other parentheses, set it equal to 0, and again, that's because of the zero product rule. So all we're going to do now is add 4 to both sides, plus 4, plus 4, so x is equal to 4. Subtract 3, x is equal to negative 3, and now you know what the domain is. Our domain is that we like every number but x equal to negative 3 or x equal to a positive 4. Those are the two numbers we're going to throw out because, again, those are the numbers that make this denominator 0. So that's the set answer. If you do the interval answer, it's going to look like this. We're going to start at negative infinity, and we're going to go up to our first problem number, which is negative 3. So from negative infinity to negative 3, we like all those numbers, but we're going to jump over negative 3. We'll pick up right on the other side of negative 3 and go up to our next problem number, which is 4. So we like all the numbers between negative 3 and 4. And then again, we're going to jump over the 4, pick right back up on the other side of 4, and shoot off to positive infinity. And that's what the interval looks like. And again, this is all about all the numbers we like, but the negative 3, which we jump over, and the 4, which we jump over. So there is the answer to number 2. Okay? Question number 3. Question number 3 says that we want to simplify this. Okay? So we've got this expression, rational expression to be specific, and we want to simplify. So I'm just writing it down real quick. So in order to simplify, we need to factor the numerator and factor the denominator. And then when we simplify, we're going to see what is in common between the numerator and denominator, and we'll cross those off. Okay? So right now you can't do any simplifying because you can't cross these guys off because it's all a part of one piece up here because of the addition and subtraction. I call these families. When you see the addition and subtraction, this is an entire family. The only way you're going to take out an entire family is if you have the same thing on the bottom. So if I want to take out this x squared, I got to take out this x squared with a minus x and a minus 72. Okay? Same thing on the denominator. This is all one family because of the addition that's going on. So first things first, we need to factor. So this top piece factors into x minus 9 and x plus 8. Okay? Again, you can either use guess and check, AC, slide and divide, or the box method to factor that. Lots of ways to factor. The denominator factors into x plus 1, x plus 8. So now that everything's factored, all we do is we look for what's in common from the top to the bottom. And you can see that this family right here, this x plus 8 matches the x plus 8 that's in the bottom. So these are the two families that are going to get canceled out because they're the same from the top to the bottom. Now all we do is write down what we have left. So we have x minus 9 all over x plus 1. And that's the answer they're going to be looking for. Okay? Make sure that you use that yellow arrow that's at the end of the box to help you out in this, because when you click that yellow arrow, so again, there'll be a box here, and then when you click in there, you'll see this like yellow arrow highlight. Open that up because that lets you use the math tools. Okay? And you'll want to use that math tool that looks like a fraction to help you out with this. And that will control all the syntax for you. All right? So use this yellow arrow to help you make these answers, because this will take care of all the syntax for you so you don't mess up on syntax for your answers. Okay? So use that yellow arrow to help you out with making this information. Very, very important. All right. So let's jump into question 4. So question 4 says simplify again. So we're going to do the same thing that we did last time, and we're going to simplify. You're going to have to, your factoring skills have got to be on point for all of this. And question 1, 2, 3, and 4, this is all still 4.1. Okay? So I've got it all written down now. Finding my mouse. So we jump over here. So if we factor, well, this problem is all about GCFs. So when we look up here, we're going to pull out a number GCF because there's a number that divides both 35 and 7. And that's 7. And that will give us 5 minus x when you pull that GCF out. Because all we do is divide all this by 7. 35 divided by 7 is 5. 7 divided by 7 is 1. So you can put the imaginary 1 there, but you don't have to. The x has to stay because we didn't do anything to it. Down below, again, this is just a number GCF. What divides both of these? 9. Good. I like that you knew that it was 9. So if we pull a 9 out, we get x minus 5. Notice that these were really, really close. The only problem is that it's a sign issue. This is a positive 5, down here it's a negative 5. This is a negative x, down here it's a positive x. So technically, one of these, if we want to change the signs, all you do is should have pulled out a negative. So one of these numbers has to be a negative. Okay? So usually what I do is I always pull the negative out of the top. So when you have families that are really, really close, the only problem is their signs. We probably should have pulled out a negative GCF. So I'm actually going to make that 7 a negative. And if I made that 7 a negative up here, that switches the signs inside. So now if you look at this, now you can see, oh, these families match. X minus 5, x minus 5. They're going to cancel out. And what do we have left? Negative 7 over 9. You could also have these for possible answers. Maybe you put the negative out front, or maybe you put the negative in the bottom. Because again, we could have pulled a negative 9 out of this one to make it match. So both of these are also still valid answers, the same as that guy. Okay? Remember that when you have a negative in a fraction, it either goes in the numerator, out front, or in the denominator. So all of these two are valid answers as well. All right. So let's jump into number 5. So question number 5 says we want to evaluate. And again, this is still 5 or 4.1. So we got this f of x equal to x over x minus 9. And then we have 4 functions to evaluate. We got f of 0. We have f of negative 4. We have f of 5. And then we have this f of x equal to negative 1. Okay? So here's what we've got for the problem. So there's that function they gave us. And here's what's going to happen. All these values that are inside these parentheses, remember this is telling you what x is. They are telling you here that x is equal to 0. They want you to plug that in and solve for y. The same thing for both of these. They're telling you that x is equal to a negative 4. They're telling you that x is equal to a 5. So all they want you to do is plug these values in for x and tell us what the answer is. So if I plug 0 all over 0 minus 9, well, 0 minus 9 is negative 9. What's 0 divided by negative 9? That is 0. So f of 0 is equal to 0. That's what they want to know. So f of negative 4, so we're going to put negative 4 divided by negative 4 minus 9. So negative 4 is on top. Negative 4 minus 9 gives us negative 13. What's a negative divided by a negative? Because you always reduce this, and that will give you a positive 4/13. And they do want the fraction. Again, if you have trouble with fractions, you can go right into your calculator, hit alpha y equals, and we could have put that entire situation in our calculator. The top was negative 4. The bottom was negative 4 minus 9. If I hit enter, there's that 4/13 I was talking about. Okay? So you can use your calculator to help you out too, because it's going to want the fraction answer in the end. And this is also a reduced answer right there. So the calculator will always kick out the reduced answer. So for f of negative 4, the answer was 4/13. So now we're going to plug in 5. So we got 5 minus 9 in the denominator, so that's a 5 on top. 5 minus 9 gives us negative 4, and that is actually our reduced answer. Again, I like to keep the negative in the numerator, so I'm just going to move the negative up top because we just talked about this from question number 4. The negative could either go up top or the negative could have went out front as well. So f of 5 is equal to negative 5/4. Okay? And last but not least, this problem is different. Notice they didn't put the number inside the parenthesis. So what you're getting here, remember that f of x, that's just a fancy way of saying y equals negative 1. So they're telling you the y value here, and they want you to solve for x. So we're going to take this negative 1 right here, and we're going to put it right here, because remember that f of x, that's just a fancy way of saying y equals x over x minus 9. So we're going to take that negative 1, and we're going to plug it in, and we're going to solve for x. Now, I know many of you are looking at this and be like, how do I solve this problem? Well, it's not that bad. Remember that this number right here, it is over the number 1. It is a fraction as well, too. This is just a proportion. How do we solve proportions? Cross multiply. So we're going to take negative 1 times x minus 9. And that's what it looks like. And we're going to take 1 times x. So that gives us x. Well, what's negative 1 times x? That's negative 1x. What's negative 1 times negative 9? Because we're distributing through on this. That's a positive 9 equal to x. We'll get all of your variables on one side. So I'm going to take a negative 1x and add it to the other side. So plus 1x plus 1x. Remember, that's a 1x as well, too. If you want to put the 1 there, you can. You don't have to. So I got 9 equal to 2x. How do I get x by itself? Divide by 2, divide by 2. And now you know what x equals. Because if you go to your calculator and put 9 over 2, alpha y equals, if you don't know how to reduce, put 9 over 2. The answer is still 9 over 2. So now we know what x is. So in that last problem, that's what we're doing. You're solving for x. And the answer for x is 9 over 2. And that's problem 5. And that right there ends everything from 4.1. So 2 domains, 2 simplify, and a couple of evaluating problems. Okay. Question number 6. So question number 6 says we want to multiply and divide. Okay? Well, multiplying and dividing is just like multiplying and dividing fractions. Okay? All right. So, when we divide fractions, remember we're going to do a thing called keep, change, flip. Okay? Keep, change, flip, or as I call it, KCF. Kentucky Chicken Fried. So I'm just writing down the problem real quick. And then we are going to talk about dividing polynomials. Okay? So here's what our problem looks like. And we're going to do keep, change, flip. KCF. Kentucky Chicken Fried. All right. So, keep means we keep the first fraction. So we're going to keep that first rational. X cubed minus 9x all over x squared minus 5x. Change means that we don't really do division. Division doesn't really exist, if you didn't know that. Division is really multiplication. In the flip, we're going to take this rational and turn it upside down. So we're going to put the x squared minus 12x plus 35 on top, all over the x squared minus 9. So we kept, we changed to multiplication, and we flipped it. And now, when we multiply, there's only 2 steps for you to do. Step number 1, factor everything that can be factored. So we need to look at all the numerators and all the denominators and make sure that they are completely factored. Once everything is factored, then we're going to simplify. That's the second step. So let's get everything factored first. So right here, x cubed minus 9x. This is a GCF problem. So we're going to pull out an x, and that will give us x squared minus 9. Okay? But this continues to factor. This x squared minus 9 is a difference of squares. So this factors into x, the GCF still there, x minus 3, x plus 3. So that is the full numerator right here factored. You have to make sure you factor it all the way down. Okay? Down here in this denominator, again, this is just a GCF, so we're going to pull out that x, and that will leave us with x minus 5. And I meant to put that right here, but it's going to be the same transition down here. There's no more factoring on this. The x squared minus 12x plus 35. This factors with x minus 7, x minus 5. Okay? Again, that's a trinomial. We've talked about all that. So you factor it with AC, guess and check, slide and divide, box method. So this numerator is x minus 7, x minus 5. And then we already talked about this guy. This is just a difference of squares. This, which is the same as that one, it factors the same way. X minus 3, x plus 3. Okay? So now that everything is fully factored, we can simplify. So again, that's crossing off what's in common from top to bottom. Please know that you could have factored everything and then done keep, change, flip. So we could have done all the factoring first. Oh, I need to put an x minus 3 there. X plus 3. So we could have done all this factoring and then done keep, change, flip. So the two steps, it doesn't really matter which one you do first. You can keep, change, flip it and then factor, or you can do the factoring and then do keep, change, flip. It's all the same. So now we simplify. So what's in common from top to bottoms? Well, hopefully you see you got an x over an x here. So they cancel each other out. We have an x minus 5 here and an x minus 5 right there. So those will cancel each other out. You have x minus 3 and an x minus 3. So those are going to cancel each other out. And you have an x plus 3 and an x plus 3. Those will cancel each other out. Lots of canceling. So let's write down what we have left. So what do we have in the numerator? Just x minus 7. What do we have in the denominator? Well, everything's gone. So if everything checks out, then you really have a 1 left. So this is perfectly fine as an answer, or you can just put x minus 7 as an answer. Both of these are acceptable. Okay? So there's question number 6. Let's take a look at question number 7. And again, we are in section 5.2. Or sorry, 4.2. So now we are in section 4.3 where we're going to add and subtract. So adding and subtracting rationals is just like adding and subtracting fractions. You need common denominators. If you do not have common denominators, then you need to get them. Cool thing about this problem, we've got common denominators. Yay for making life easier. So, since we have common denominators, that means we already know that this denominator is going to be x minus 3. You leave it alone. When you add and subtract, you leave the common denominator alone. Then all we do across the top, across the numerator, is combine like terms. Well, are any of these going to get together? No. But they don't disappear either. We just have to write them all down. So we've got x squared plus 2x and then minus 15. So now we're right back to what we did and what you learned in section 4.1. You need to simplify this. So because we had that common denominator, all we had to do was combine like terms. And then in the end, you need to simplify this, like what we do in 4.1, like what we did with question 3 and question 4. So does this numerator factor? You betcha. It factors into x plus 5, x minus 3. So the denominator does not factor. So do we got anything in common from top to bottom? Yes, we do. We have the x minus 3's cross off, and that leaves us with x plus 5 in the numerator. And since everything's gone in the denominator, that's 1. Or you can just call it x plus 5. Both of these are the same answer. Okay. Moving on to question number 8. If memory serves right, I believe this is another adding, subtracting, but we have unlike denominators. All right, so let me write this down. So we got x over x squared plus 4x minus 12 minus 7 all over x squared plus 13x plus 42. So obviously you can see that these are not like denominators. So in order to add and subtract fractions, we need to get common denominators. So the first thing we're going to have to do is find that LCD. What is the least common denominator? Well, before we can do that, these denominators need to be factored. So x squared plus 4x minus 12, it factors into x plus 6, x minus 2. Because again, you can use guess and check, AC, box, slide and divide. And the same thing over here. Use those same methods, and you get 7 over x plus 6, x plus 7. Okay? So usually when I talk about the LCD, what I tell my classes is that it's made up of all of the denominators. So I have a denominator of x plus 6, x minus 2, and I've got a denominator of x plus 6, x plus 7. So in my classes, I tell them to write down the first denominator because it has to be made up of it. And then I have them compare with the next denominator. So right now our LCD is x plus 6, x minus 2, because all this information covers this first denominator. Both of these parentheses are right here. But when I look at the next parenthesis, do both of these parentheses cover the x plus 6, x plus 7? No. The x plus 6 is covered. See, it's right there. But what's missing is the x plus 7. So I need to write down an x plus 7 because that will cover this. See, it's made up of both denominators. There's the first denominator. There's the second. See, both denominators are there. So now that we know what the common denominator is, we can adjust our fractions. I need x plus 6, x minus 2, x plus 7 as a denominator of my first fraction, and I need x plus 6, x minus 2, x plus 7 as a denominator for my second fraction. So here's what I have, x plus 6, x minus 2. Here's what I need. What's missing? The x plus 7. So if I multiply the denominator by x plus 7, I gotta multiply the numerator by x plus 7. So this is just going to distribute through. What's x times x? That's x squared. What's x times 7? That's a positive 7x. So here's what I've got. Here's what I need. What's missing? This is missing the x minus 2. So if I multiply the denominator by x minus 2, I have to multiply the numerator by x minus 2. And again, distribute. 7 times x is 7x. And 7 times a negative 2 is negative 14. And now we're right back to what we just did, like on problem number 7. I've got my common denominator, x plus 6, x minus 2, x plus 7. I need to combine like terms across the numerator. Now here's where you have to be careful. Because of subtraction, you need to be careful because of what's going to happen right over here. Okay? So because this is subtraction, that's going to change all of these signs right here because we are subtracting off all of this. So our first numerator stays the way it is. But in the second numerator, remember, it's like we're subtracting off all of that numerator. So it's like taking a negative 1 and multiplying it through. Well, what's a negative do to a positive 7? Makes it a negative 7. What's that negative do to a positive negative 14? Makes it a positive 14. Okay? So what do we have left? Well, combining like terms, these x's are going to get together, but they just cancel each other out. So that gives us x squared plus 14 in the numerator. what do we have down here in the denominator? X plus 6, x minus 2, x plus 7. So, now that we have our single rational here, we do any factoring of the numerator to simplify down. Does this numerator factor? And no, it will not. I know some of you might be trying to do difference of squares up here, but this is not a difference of squares because that's an addition sign. Okay? So, this numerator doesn't factor. So, is there any simplifying? Is there any crossing off? No, because nothing up here can cancel with anything down there. This is, in fact, the answer. Okay? So, you just leave it. All right. Let's jump over to question number 9. So now we are in section 5.4. Sorry, 4.4. Keep jumping to chapter 5. We're not in chapter 5 yet. And they want us to simplify the complex fraction. Okay. The easiest way to simplify the complex fraction is to do what we call clearing the fraction. Because all of you hate fractions, why continue to work with them? Okay? So I have written down the problem. So we want to go ahead and clear all the fractions in the numerator and clear all the fractions in the denominator. In order to do that, we're going to multiply everybody by the LCD. We're going to be like, it's like playing Oprah Winfrey. Okay? You'll see what I mean by that here in just a second. So the LCD is made up of all my denominators. So what are my denominators? Well, I have an n squared, and I also have an n. See, I got another n squared there, so I don't need to worry about rewriting it. So my denominator needs to be made up of both of these. Again, if I write down the first denominator, it's just n. But does one n cover it in squared? No. So I have to make it n squared. That's my common denominator, because n squared covers n squared, because there's two n's here, two n's there. And two n's definitely cover one n.
So we now know that the LCD, the least common denominator, is n squared. So we're going to play Oprah, and everyone's going to get multiplied. So the 1 got multiplied by n squared. The 16 over n squared got multiplied by n squared. The 1 over n gets multiplied by n squared, and 4 over n squared gets multiplied by n squared. Again, the purpose of this idea is to clear the fractions. So since there's no denominator right here, there's no simplifying, so n squared times 1 gives us n squared. Now over here, again, the purpose of multiplying by this is to clear out the fraction. So this n squared cancels with that n squared. So what does that leave us with? Minus 16. Now over here, this n squared is going to help cancel out some of this. So this n completely goes away, but it doesn't take out all of the n squareds. It just takes out one of them. So we have n to the first that's left up there. So n times 1 is just n. And then again, just like what happened a second ago, these n squareds are going to cancel each other out, leaving you with plus 4. And now, all this is just a simple rational that needs to be reduced. In order to reduce it or simplify it, we got to factor everything. So this is a difference of squares. So n minus 4, n plus 4 is how that numerator factors. And then we still have n plus 4 on the bottom, because that does not factor. What cancels out? The n plus 4s. Leaving us with n minus 4 all over. Since this is all gone, it's the number 1. Or you can just call it n minus 4. And there is how we simplify that complex fraction. Okay? So now let's jump into question number 10. Oops, wrong one. Question number 10. Too far. So question number 10 says solve the rational equation. So this is coming from section 4.5. So we got this negative 3 over 4x. I'm just going to put that negative within the numerator, as you'll see here in a second. I'm just writing out the problem. Plus 5 over 2x equal to 5. So we want to solve. Okay? So here's the equation that we're looking at. And like I said, I just moved that negative that was in front up to the numerator because we can get away with that. So in order to solve this, again, just like what we did in problem number 9, get rid of the fractions. No one likes to work with the fractions. So we want to find that LCD. And again, for the LCD, look at your denominators. It's 4x and 2x. So I'm going to start with my first denominator, 4x. I'm going to write it down. 4x definitely covers 4x. Does 4x cover 2x? Absolutely. These x's cover each other, and 4 is divisible by 2. So 4x is our LCD. So again, play Oprah. You get a 4x, and you get a 4x, and you get multiplied by 4x. Everyone gets a 4x. So, doing that, what's going to happen to these 4x's? Again, we're clearing the fraction, so they just cancel each other out. And that leaves us with negative 3. Plus, well, what's going to happen between these two? Well, the denominator fully goes away. The x goes away, but this 4 that was right there is divided by 2, and that guy becomes a 2. So what we have left is 2 times 5, which is 10. Equal to, well, nothing cancels out over here, so what's 5 times 4? 20x. And now this is something that we can solve. So what's negative 3 plus 10? Well, that's 7 equal to 20x. How do I get x by itself? Divide by 20. Divide by 20. So now that we know that x is 7 over 20. Now, this may be our answer, but before we can do that, we need to check it. When you are solving rationals, you need to take your answer and plug it back in and make sure that it does not equal 0 in the denominator. So remember that this denominator there was 4x. If I take 7 over 20 and plug that in for that denominator, does that give me 0? No. It gives me 14 over 20. Or sorry, not 14 over 20. It would give me... kind of trying to do this in my head. That cancels out. It gives you 7 over 5. That's definitely not 0. And then the same thing over here. That denominator was 2x. If I plug 7 over 20 in here, does that give me 0? No. It gives me 7 over 10. So since these are not zeros, this answer is valid. Okay? So the answer is, in fact, 7 over 20. All right. Let's talk about number 11. Oh, I keep pushing the wrong one. So number 11, again, it's another solve problem. So again, this is 4.5. So we got 6 minus 11 over x equal to, again, I'm going to put that negative in the numerator, over x squared. So going over to my DocuCam. So again, find that LCD. My denominators are x and x squared. What is the LCD going to be? I write down my first denominator. X covers x, but it doesn't cover the x squared. So we just up the power. Now x squared definitely covers x squared. And x squared is made up of 2 x's, which certainly covers 1. So again, Oprah, you get an x squared, and you get an x squared, and you get an x squared. Everyone gets an x squared. All right. So what's x squared times 6? Well, that's 6x squared, because nothing cancels. Again, between these two, this x goes away in the denominator, but that only cancels out one of those x's out of the two up top. So we have minus, what's 11 times x? 11x. Equal to, well, what's going to happen between these two? They're going to cancel each other out. Gone, gone. And that gives me negative 3. So now we're going to add 3 to both sides. And that gives us 6x squared minus 11x plus 3 equal to 0. Because we have to be equal to 0 because we need to factor. This thing needs to factor. Okay? That's why we had to move the 3 over here, because we want a factor to solve. So when we factor this to solve, we're going to get the following information. So trying to work this thing out in my head. Okay. So we will have a 3x and a 2x. And that will give us, we'll need a 1 here and a 3 there. And that should be the factoring of that, because that's 6x squared. 3x times negative 3 is negative 9. Negative 1 times 2x is negative 2x. So negative 9x, negative 2x, that's negative 11. And a negative 1 times a negative 3 is a positive 3. Good. So there it is. I did a little guess and check. But again, AC, slide and divide, box method, all work. So we set these equal to 0. And now we'll be able to get our answers. Add 1 to both sides. So 3x is equal to 1. Then divide by 3. X is equal to 1/3. Add 3 to both sides. So 2x is equal to 3. Divide by 2. X is equal to 3/2. So what we need to know is, does this create 0 in our denominators? Well, if we come back up here, these denominators were x and x squared. So if I plug 1/3 in here to both of these, this gives us 1/3. This gives us 1/9. That's definitely not 0. So 1/3 is a valid answer. And then if we plug in 3/2 here, so this is 3/2. This gives us 9/4. That's definitely not 0. So 3/2 is also a valid answer. So we have 2 for this one. 1/3, comma, 3/2. And there we go. All right, question number 12. So in question number 12, we are solving the literal equation. So we got 8 over m plus 2 over n equals 3p. And we want to solve for m. Okay? So we want to get this by itself. In order to do that, just like what we've done before, we've got to get rid of the fractions. So we need to find that LCD. And the LCD for this, since our denominators are m and n, will be made up of both of those. mn. That's our LCD. Everyone's going to get multiplied by mn. So you get mn, you get mn, and you get multiplied by mn. So what's going to happen? M cancels out, and that gives us 8n. The n cancels out, and that gives us plus 2m. And then over here, all these just multiply together, so that gives us 3pmn. Okay? Again, we need m by itself. Now I have 2 of them. So that means I need to get all my m's on one side. So leave this 8n alone, and let's subtract 2m to the other side. So we have 8n equals, now do these two get together? No, because they don't have common variables. But they don't go away, so what we have is 3pmn minus 2m. See how we have all the m's on one side? And look, both of these terms have an m in common. Pull that out. That's a GCF. So if I pull m out, I get 3pn, because I took the m out of that, minus 2, because I took the m out of that guy. And how do we get rid of multiplication? Because we want m by itself. We divide by 3pn minus 2. Divide by 3pn minus 2. So m is equal to this answer that's right here. 8n all over 3pn minus 2. And there you go. All right, question number 13. And again, 12 came from 4.5 as well. Question number 13, again, coming from 4.5. You can see lots of 4.5 questions. So, question number 13, word problem. It says, Evan can type a report in 4 hours, and his older sister takes 8 hours to type the same report. Working together, how long should it take? All right. So, hopefully your professor kind of gave you an idea about this, but the setup of these problems looks like this. This is how long it takes for the first object. Okay? Usually it's time. So the first object's time. Then we're going to add that together with the second object's time. And that will give us x, which x is when they work together. Time. That's how these problems work. You're setting up a rational equation to solve. So our first object in this was Evan. How long did it take Evan to work? It took him 4 hours. So our first fraction looks like 1 over 4. Plus, our second object is his sister. We don't know her name. So his sister, though, takes 8 hours. So that's 1 over 8. We want to know how long does it take for them to work together. So that's 1 over x. So to solve this, again, we got to get rid of the fractions by multiplying by the LCD. So my denominators are 4, 8, and x. So if I write down my first denominator, that's 4. Does 4 cover all three of these? No, because it does not cover 8. So let's up this, and let's say we make this 8. Can 8 cover 8? Absolutely. Can 8 cover the 4? Absolutely, because 8 divided by 4 works. Does 8 cover x? No. So how can I fix this? Add an x to it. There's the LCD, because 8x covers everyone in here. The x covers the x, the 8 covers the 8, and the 8 covers the 4. So again, we play Oprah. You get an 8x, and you get an 8x, and you get an 8x. Everyone gets an 8x. So, what's going to happen here? The 4 goes away, and it only cancels out part of the 8, which becomes a 2. So what's 2x times 1? 2x. Plus, this 8 cancels out with that 8, leaving you with x times 1. So that's x. Equal to, what's going to happen over here? The x's both cancel each other out, leaving you with 1 times 8. And there you go. So what's 2x plus 1x? That's 3x, equal to 8. How do I get x by itself? Divide by 3, divide by 3. So x is equal to 8 over 3 hours. Okay? With that being said, because this is a real world problem, I think they want the answer as the fraction, if I remember correctly. It doesn't say anything about rounding. Let me double look. Yeah, write your answer as an integer or reduced fraction. So that is our answer. Although that's weird, thinking about this as a real world problem. Why would anyone say it takes us 8/3 of an hour to work together? That's just weird. So, really, this is actually a better answer would be that it takes 2.6 hours. It's actually 6 repeating, just so you know. That would be an even better answer, but they want the fraction, so we have to leave it like that. All right. So, question number 14. Now we start chapter 5. So this one right here is all about reducing. So, the first thing I would do if I want to reduce this is put it into the calculator, see if it works. So let's take the fourth root of 256. So I go to my calculator, math, scroll down to number 5, because that's where we can do multiple roots. Put in 4, and our number is, once we scroll in the inside, 256. Hit enter. Hey, it worked. Now you've reduced it. There you go. See if it works in the calculator. If it does, great. Now you know the answer. If it doesn't, well, then we'd have to reduce it the way that we reduce radicals normally. Okay? And most of you reduce radicals by splitting them up into two different radicals. One with a perfect square, or in our case, it would have been a perfect fourth. And then the other radical would have been the number that multiplies by it. I'm sure we'll see that soon enough. All right, question 15. So 14 was from 5-1. Question 15 is from 5-2. So they want us to take this decimal, writing it down real quick, and turn it into scientific notation. Okay? So here is our decimal. So we're going to turn this into scientific notation, which means that we need to make it as a number times 10 to a power. Now remember that this number here has to be between 1 and 10. The power will be a positive power if you move to the left. The power will be a negative power if we move to the right. So up here, we're going to be moving our decimal to the right. So we know that our answer will have 10 to a negative power. So that power, that number here, is how many times we move. So if I move once, is that between 1 and 10? No. If I move twice, is 0.0000421 between 1 and 10? No. If I move 3 times? No. 4 times? No. 5 times? So 0.421, is that between 1 and 10? Not yet. So how many times did we have to move? 6. And what is our number that's between 1 and 10? It's 4.21. That number is definitely between 1 and 10. And there is the scientific notation answer. Again, that's from 5.2. All right. Question number 16. So in this one, again, this is 5.2. Here's what's awesome about this problem. I mean, I'll show you the math behind it, but in this one, I would just go to my calculator and plug it in. Okay? Parenthesis, negative 125. Close the parenthesis, and it's got a power of a fraction. So alpha y equals is your fraction key. Negative 4 over 3. And there's your answer. 0.000116. Now I'm sure it wants it as a fraction. So if you hit alpha y equals, this number 4 turns it into a fraction. So scroll down to it, hit enter, and that will turn our answer to a fraction, which is 1 over 625. And there's your answer. Just let the calculator do the work. Now, let me show you what the math does. Okay? So, again, this was our problem. First things first. If you have a negative exponent, that means we need to move. And right now, this number is in the numerator. Since this is in the numerator, where is it going to move? It's going to move to the denominator. So it looks like this. See, once it moves, it's happy now. That's an exponent rule. And again, this problem is coming from 5.2 as well. So now we have a rule that says that if you have a number to a fraction exponent, that what this fraction exponent, this rational exponent really is that this is the power of an exponent, and this is like the index of the root. So what we have here is that this problem right here really looks like this as radicals. This is the exponent, which is 4. This right here represents the index of a radical. So it's the cube root of negative 125. So we can do the cube root of negative 125. That's pretty easy. The cube root of negative 125 is a negative 5. And then all we're going to do is take that to the 4th power, which leads you right back to that answer of 625. Okay? That's really the math that's going on. All right? Question 17. Again, just let the calculator do its work. So, question 17, this is coming from section 5. I believe this is section 5.4, because we are dealing with rationalizing. So in order to rationalize this, you should have learned in section 5.4 that you need to multiply the top and bottom by the radical that is down in the bottom. However, because there is addition here, what you really need to multiply is by the conjugate of the bottom. Remember, a conjugate, if I have a plus b, the conjugate is an a minus b. If I have an a minus b, the conjugate is an a plus b. So, in order to get rid of this square root of 28, I need to multiply by the conjugate. What's the conjugate of addition? Subtraction. And you multiply top and bottom. Cool thing is, because these are conjugates, the middle term will cancel out. So all we really need to do is multiply the first, which 3 times 3 is 9. And then multiply the last, because the middle piece of foiling this will actually cancel out. And what happens when we take a radical and multiply it by itself? Okay, when you have two radicals that are the same, all that happens is the number pops out underneath, and a positive times a negative is negative. So whenever you multiply two radicals that are the same, all that happens is that number pops out underneath. I call this method the Florida because all you're multiplying is the first and the last. You don't have to do the I, O, or the O in the full FOIL there. Now up top, if there is foiling, you do have to do that. But when you multiply conjugates, all you have to do is Florida the bad boy. Okay? So up at the top, we do need to distribute this through. What's 3 times 3? Well, that's 9. What's 3 times a negative square root of 28? Negative 3 square roots of 28. Okay? So now doing a little cleanup, we got 9 minus 3 square roots of 28. 9 minus 28 in the bottom gives us a negative, what's that, 19? Okay? Now, before we're not done, because the question is, can this square root of 28 break down? And it can. Okay, so we need to find the biggest perfect square that divides it. So 28 divided by 4, that's our first perfect square because it's 2 times 2, 2 squared, is 7. Let's try the next one. 28 divided by 9. Did that work? Nope, because 9 is a perfect square. 3 times 3, 3 squared. Let's take 28 divided by 16, because that's the next perfect square after that. Nope, and 16 is a perfect square. 4 times 4 is 4 squared. And then the last one you would try is 28 divided by 25. And no, that doesn't work, because again, 25 is a perfect square, 5 squared. Okay, we don't try the next one after that because it's 36. 36 is definitely bigger than 28, so it'll never work. Okay, so our biggest perfect square that divides it is 4. So this radical does break down into the square root of 4 and the square root of 7, because 4 times 7 is 28. What is the square root of 4? Well, that's 2. Square root of 7 stays because it's not a perfect square. It has to stay. So this piece right here is going to come in and replace that radical of 28. So we got 9 minus 3 times 2 square roots of 7 all over 19. Sorry, negative 19. Doing a little cleanup on top. What's 3 times 2? Well, that is 6 square roots of 7 all over negative 19. Now, the last thing you got to look at are these numbers right out front. Is there anything that can reduce these numbers? Is there a number that divides all 3 of these? And no, there's not. So this is one of the final answers you could have. I also know that sometimes our iMathAS likes to take this negative and just, again, remember, we don't have to have the negative in the bottom. We can move it out front. So we could have a negative 9 minus 6 square roots of 7 all over 19. Or you could take and distribute the negative through the numerator and have a negative 9 plus 6 square roots of 7 all over 19. That's if you took the negative and put it through the top. All 3 of these answers are the same. Okay? So that's important to know. And that right there is from 5.4. Rationalizing the denominator. And you had to use a conjugate. Okay. Our next problem, problem number 18. We are jumping into 5.5. So we're going to solve this radical. So we got 3 square roots, or the cube root of 3x minus 334 plus 1 equal to negative 6. Okay? So here's our problem. Well, the first thing is, with all of these, as a note, you need to get the root needs to be isolated. You got to get the root by itself. That's important. So I got to get rid of this plus 1 over here. How do I get rid of the plus 1? Subtract 1. So that gives us the cube root of 3x minus 334 equal to, well, negative 6, negative 1 is a negative 7. Now that this root is by itself, we can go ahead and raise both sides to a power that will take care of it. And what power takes care of a cube root? A cubic power. So the cubic takes care of the cube root. Gone. Gone. So that gives you 3x minus 334 equal to negative 7 cubed. I do not know that off the top of my head. Know that when you put negative numbers in the calculator and you're going to raise them to a power, I will put them in parentheses always. So negative 7 cubed is negative 343. All right. Going back to our problem. Solve for x now. Add 334. So that'll give us 3x equals, I don't know that answer off the top of my head, so we're going to add 334 to that answer. That gives us negative 9. And then we come back. Oops. Divide by 3, divide by 3. X is equal to negative 3. Now again, just like what we did with the rational equations, we need to check this answer. We need to take and plug this in and make sure that this side actually comes out to a -6. So this is the check. Got to plug it in and check it. And unfortunately on this one, you got to check the full thing. So we got to plug it in and make sure that everything is working out to what it should be. So we got 3 times -3 minus 334 plus 1 equal to -6. 3 times -3, that gives us -9 minus 334 plus 1 equal to -6. -9, -334 gives us the cube root of -343 plus 1 equal to -6. The cube root of -343 is actually -7 plus 1 equal to -6. And -7 plus 1 is definitely a -6. So it checks out. So this is the answer to number 18 for sure. Validated. It is -3. Okay. Almost done. Yay! Number 19. A word problem. So it says, on a sunny day, a flagpole and its shadow from the sides of a right triangle. Oh, sorry, not from its shadow. And its shadow form the sides of a right triangle. If the hypotenuse is 13 meters long and the shadow is 9 meters, how tall is the flagpole? So this question right here is jumping back into 5.1. Okay? And it's talking about a right triangle, which means that we're going to be talking about the Pythagorean theorem. And look, right here, it tells you what to round to, the nearest tenth. So that's going to be 1 decimal. So if we go into our paper, it says we got a tree. So I'm going to draw a tree. So here's my tree. And it's got a shadow along the ground. So there's my tree shadow. It says it forms a right triangle. So there really is a right triangle here. There's this guy all the way out to there. See, there's my right triangle, and that's the right angle that's right there. Okay? So if I go back to the problem, because I forgot everything, it says the hypotenuse is 13 meters long. Okay? So looking at this, we know that this guy right here, the hypotenuse, 13 meters, because the hypotenuse is the longest side, and it's never ever connected to the right angle. And it says the shadow. Well, where's my shadow? That's right here, and I think it was 9 meters. Yep, 9 meters tall. They want to know how tall is the tree. Just to double check. Oh, how tall is the flagpole? Sorry, it was a flagpole. I drew a tree. Same thing. My bad. Flagpole, tree, all the same. So they want to know how tall is the flagpole. So let's just say our tree is the flagpole. All right. So remember, this is Pythagorean theorem. That's a squared plus b squared equal to c squared. The x and the 9, these are what we call the legs. So one of these is A, one of these is B. I'm just going to let this guy be A. And I'm going to let the 9 be the B. The hypotenuse is always the C. So now you know who is who. We just plug it in. So what's A? That's x squared. Plus what's our B? That's 9 squared. Equal to what's our C? That's 13 squared. So second step, we need to square everything. 9 squared is 81. 13 squared is 169. Now we just subtract 81 from both sides. So x squared is equal to, again, I don't know, 169 minus 81 off the top of my head. So I'm just going to use my calculator. So that's 88. And how do I get rid of something squared? Square root, square root. X is equal to, well, what is the square root of 88? Well, we hit second square root. 88 equals, and again it says round to the nearest tenth, so the 8 says, hey 3, go up. So our answer is 9.42. meters. That's how tall the flagpole is. Or in my case, I drew a tree. All the same. Okay? There's 19. And last but not least, problem number 20. All right. Problem number 20 is coming from 5.6. So they want you to divide the complex numbers. And in the end, you need to write the answer in standard form. So -7 plus I all over -6 minus 3I. Okay? So you understand standard form for a complex number looks like A plus BI, where this is what we call the real part, and this is what we call the imaginary part. Okay? All right. So, how do we deal with this? Well, remember I is like the square root of a -1. So that means we have a square root in the denominator. We can't deal with that. And we also have addition and subtraction going on down here. So that means we're going to bring back that conjugate idea. Although this time it's called a complex conjugate. Complex conjugate. And for the complex conjugates, if you have A plus BI, the conjugate would be A minus BI. If you have A minus BI, the conjugate would be A plus BI. So I've got subtraction here. That means I'm going to multiply top and bottom by -6 plus 3I. Because that is the conjugate of subtraction. Okay? So again, down here in the denominator, all you're going to do is floor to this because they're conjugates. Middle term will cancel out. So what is -6 times -6? That's a positive 36. What is -3i times positive 3i? That will give us a -9i squared. Now, hopefully you remember from your professor telling you that anytime you have an I squared, that really represents a -1. And we need to represent it as such. Okay? Because really what's going on is you're taking the square root of a -1 times the square root of a -1. And as we talked about earlier, when you're multiplying two radicals and the same numbers underneath, that number will pop out. That's really what's going on with an I squared. So up here, this denominator is really 36. Well, what's a -9 times a -1? Because that's really what I squared is. That's a positive 9. So in the end, our denominator is a 45. Because 36 plus 9 is 45. All right, now the numerator. The numerator, we actually have to FOIL all this out. Okay? So we're going to take -7 times a -6, which is a positive 42. We're going to take a -7 times a positive 3i, and that will give us -21i. We're going to take I times a -6, which will give us a -6i. And last but not least, we'll take I times 3i, which will give us a positive 3i squared. So again, kind of doing some cleaning up here. That I squared becomes a -1. -1 times 3 gives us a -3. So now we can combine like terms. So the 42 and the -3 get together, and that gives us 39. And then our two i's will get together, which will give us -27i. So the question is, when we deal with this, we're going to separate these out into their fractions because it must be in that standard form. So just remember that whenever you have addition and subtraction in the numerator, this really just over a single denominator, it means that it's two fractions, where both fractions have that 45 in the denominator. So you got 39 over 45 minus 27 over 45, and we'll put the I out to the side. See? This is still the same thing. Now just let your calculator reduce these down for you, and you got your final answer. So go to the calculator, alpha y equals 39 over 45. So that first fraction is 13 over 15 minus, go to your calculator, alpha y equals, and we've got 27 over 45. So that second fraction is 3/5 I. So here's what the final answer in standard form for this looks like. 13/15, that's the real part, minus 3/5 I, that's the imaginary part. And that is your Module 3 test. I bid you good luck.